name is Genoveva Burca. I'm a neutron imaging and diffraction scientist working at the IC's Neutron and Muon spallation source, a center for research in the physical and life sciences operated by the UK Science and Technology Facilities Councils near Oxford. ICES produces beams of neutrons and muons that allow scientists to study materials at the atomic level using instruments often described as supermicroscopes. My research interests lie in developing and applying advanced imaging and characterization techniques to follow the behavior of natural and engineered materials in real time and in 3D, often as they operate under demanding conditions. These insights can help understanding of how structure forms and gives rise to specific properties, as well as how degradation occurs under realistic service conditions in real time. Applying neutron imaging in life sciences is both challenging and exciting, with a high level of complexity and novelty, requiring a bold, creative, interdisciplinary approach. Mapping the three-dimensional carbon distribution in soil, understanding how plant roots respond to different soil structure and water distribution. Effects of environmental fluctuations are few examples of neutron imaging applications which could help us to tackle some of the current climate change challenges. So in 2016-17, when IMAT was open, we tried to open also new research fields with neutron imaging. And initially I went to some X-ray conferences to present neutron imaging capabilities available at ICES. And when I met people interested in plant soil research. And I explained them what we can do with neutrons, how neutrons can complement X-ray measurements, and then we discussed feasibility of some projects, experiments, and in this way we started this collaboration. Working with live samples, live plants, for example, is very difficult because traveling with samples from one area to the other one, bringing them for experiments, it's a little bit complicated because they evolve during the time. They don't wait for us to measure them. So in this way, I said, okay, maybe we can make a facility, a small facility, close to the instrument for users to prepare the samples, and in this way help them to tackle this issue with traveling and transport. So we have a small research greenhouse next to IMAT, where users can come, we can prepare samples, grow plants there, and then do measurements when the beam is allocated. So neutrons and X-rays have different interactions with materials. With X-rays, we can see soil distribution, minerals in the soil. On the other side, with neutrons, we can see water distribution because neutrons are sensitive to light elements, and water is mainly made by hydrogen. So in this way, we can complement the both measurements. For this reason, I initiated this collaboration with Diamond, mainly with I-12 instrument, and most of my users and my collaborators, once they do measurements here on IMAT, then we can move a sample straight to I-12, of course using greenhouse for keeping the plants happy, and then put together the complementary measurements for exciting publications.